So now I'm going to be diving into what I believe is the next simplest example of how these operators and how charms work with with OSM. And that is going to be orchestrating a physical network function. This is going to be relatively simple set of operations, but they're going to do concrete actions. So that's why I think it's going to be a good introduction. So here's our big picture again. What we're going to be looking at is this firewall here, which is, simply put, VIOS software. So we're going to be showing how we're going to be able to manage some rules in the firewall using actions. So the first thing that I'd like to do is do a little bit of a segue into what's a physical network function and what's a virtual network function. Found this lovely little diagram that explains it, I think, pretty well. So PNF is a fixed asset. It's a higher cost unit. It's fragile. It needs care. We've got to, basically it's already there. It comes in one shape, one size, and we don't, manage the life cycle of it. Whereas a VNF is a low cost unit. And the important thing is it is recyclable. Now, what do I mean by that? What I mean is that OSM is capable of creating it and destroying it on demand. This is the key differentiator between physical and virtual network functions. A lot of physical network functions are purpose-built appliances. They're, a rack unit, such as a firewall, that, when you order one, they're going to ship you the hardware with the software on it. And you're not going to have any control over that software other than the management API that they give you. You're not going to be able to perform, oh, let's upgrade the software now, or, let's make a change to it and redeploy it, or let's bring up a second instance of it, because that second instance would require more hardware. You would need to buy another unit from the manufacturer. Whereas virtual functions, you can create as many copies as you want, and as we'll see tomorrow in our scaling demonstration, you can create them on demand to accommodate load, and then when that load goes away, you can free up those compute resources. So, does a PNF always mean bare metal? No, not exactly. A PNF is a network function that is tightly coupled between the software and hardware that it's running on. It's a fixed function, and it's purpose-built. But it could be a virtual machine. It's just a virtual machine or something running that we are not going to have any life cycle control over. So it could be a virtual machine that was already installed by, say, for example, your IT department, because it's a security appliance and they want to manage its life cycle. They don't want OSM to be able to spin up a second instance of it and perhaps mess up the network firewall rules or the network routing and topology that the IT department and security department has so carefully crafted. Now, we all want to get to the point where things like that become obsolete and everything is a virtual function. But as we mentioned, reality is messy. That's not always going to happen. So for the purposes of demonstrating this week's Hackfest has this physical network function running as a VM, just to make sure that we're clear that physical network functions could be virtual appliances. Now, VNFs as well, just to throw a wrinkle at it, a virtual network function doesn't always have to be a VM or a container. You see, inside of OpenStack, there is another project called Ironic. What Ironic does is it takes previously commissioned bare metal servers, and it exposes them to OpenStack as if they were VMs. So when I use Ironic, I can say OpenStack server create, and it'll create what looks like a virtual machine. But in the background, what's actually happening is Ironic is taking the image that was stored in OpenStack, copying it to the physical disk, and then booting that bare metal server with that image. So the bare metal server is running the equivalent of a virtual machine, but it's running it without a hypervisor. Now, it's called virtual at that point because I can, at a moment's notice, tell Ironic, oh, destroy that and deploy a new set of software to that exact same bare metal hardware. So reality is messy. You've got virtual machines running on bare metal, and you've got physical network functions running in virtualized environments. OSM understands and manages all of this complexity. So, what are PNFs? PNF is a physical network function, and that basically refers to the endpoint that provides the capabilities of that function. PDU is another term which refers to the physical deployment unit. That is the instance of the appliance that will be incorporated as a network service. And then we have hybrid network functions, which are functions that can be composed of both physical and virtual elements. At the end of the day, there's no fundamental difference between any of them. OSM, through the Sol6 API, actually OSM has always treated these as equivalent and given you the capabilities of managing them to the best of the specifications and try to abstract that from us. So how do we manage a PNF? OSM has to be told about the PNF because OSM isn't launching this. It's not telling OpenStack or Kubernetes or VMware or Amazon Web Services or anything. It's not saying, hey, create me an instance of this. This is something that already exists in your network. So we have to tell OSM, what's the IP address? What are the credentials that I use to talk to it? Or what API endpoint is there? And what network protocol do I need to be able to speak with this? So when we actually deploy this as a network service, OSM isn't actually deploying anything. It is merely creating a model of the network service so that we can talk to it the same way we talk to any other network service. Once this information, IP address, etc., has been registered with OSM, and we launch the model to represent it, we can communicate with it as if it were a VM that OSM launched. So once it's launched, OSM will create this execution environment, which we said could be in LXD container or it could be a Kubernetes container. It's your choice which type of environment you want to use, but it will create this execution environment, and then our proxy ops code basically will be injected into that environment and will be capable of running that code to communicate with the PNF. So the PNF is left pristine. We're not making any modification on it, but we're bringing up an environment where our code can live and do what it needs to in order to manage that physical network function. Sidetrack into VIOS. So our firewall is being implemented by the open source VIOS router. What's the difference between firewall VNF and firewall PNF? The P and the V. Basically, firewall is the function that's being provided, and if we're treating it as a PNF, What that means is the software must already be installed. It must already have an IP address. We must be able to reach that IP address from OSM, and OSM must be told about where those, where that IP is and how to do it. In the case of a firewall VNF, that information would be encoded into the VNF descriptor. What network should it use? Does that network need to be created, or does it already exist? Because OSM can create the network on demand. What image is being used in OpenStack to launch this? Or what image from Docker is being used to instantiate the Kubernetes container? So in a PNF, the software is already installed. In a VNF, OSM will cause the software to be installed in a new virtual unit that is created on demand for that software to live in.
Yeah, so basically for VNF, it will be on the runtime.
Yes.
As we described earlier, that there is a design time and there is a runtime. So for the PNF, all will be done on the design time. And yeah,
well, for the PNF, somebody is going to need to log into OpenStack or go into your data center and install the appliance.
Mm-hmm.
Right? So PNFs don't have a life cycle inside of OSM. They are physically something that already exists in the environment, if that makes sense.
Mm-hmm. Okay. Yeah.
So our example with Vias here. So Vias is neat software in that it could be a physical platform or a virtual platform. We can have it run on, embedded small x86 boards. It could be run on a big server. It can be run under KVM, Xen, VMware, Hyper-V, you name it. So we can use Vias to do in this environment to do different things. We could have installed it as a physical appliance and had it already up and running for you, but I didn't have that many servers. It is completely free and open source. It's got well-documented internal APIs and build procedures. It has a scriptable CLI, and importantly, it already has Ansible Playbooks for configuration. Why is that important? Well, that means there's less code for me to write. All I need to do is tell the Juju charm, execute this Ansible playbook with these parameters, and it will go ahead and do that for me, and it'll do the configuration for me. There's a lot less work that is needed, and I could develop and test some of these actions with Ansible before even launching it in OSM. So when we're talking about design time, it gives you a lot more flexibility and a much quicker turnaround time to be able to get in under the hood and play with Ansible directly and make sure it's doing what you want it to, even before you bring it into a larger orchestration engine. In our example, the Vias firewall is going to act as the default gateway for the private network. Private network is where we're going to be launching the virtual desktop that your employees will use. It is going to masquerade all outgoing traffic. What that means is there is one point of presence for our network on the internet. It is the 172.21.19.URID. So that's going to be the one IP address that you're going to interact with, and that is going to get you inside your private network from that point forward. You won't be talking to the individual instances. You will be going through the firewall. And if you had 10 employees with 10 virtual PCs all in this private network, every single one of them is going to say, go to YouTube. That means the one VM up here is going to say, hey, get me to YouTube, and another one's going to be saying, hey, get me to Google. But we only have one IP address on the internet. So the VIOS router is responsible for knowing that employee 1 is going to YouTube. Therefore, when YouTube responds back with a video, that needs to go back to the desktop of employee 1. And employee 2 is going to Google. So the response needs to come back from Google back to employee number 2. So that is all the responsibility of VIOS. And that's what we mean by masquerading the traffic. It receives the request from the individual desktops, and then it rewraps that and acts as if it were asking for that page. And when the response comes back, it unwraps it and sends it back to the origin. So how does a primitive run? David already covered a little bit of this, but just a quick refresher. OSM creates the execution environment where our operational code will run. OSM, we then tell it through its interface, hey, execute an action for me. That action in the VIOS case is going to be, we're going to run a specific Ansible playbook with data that came from OSM. So I'm going to tell OSM, hey, I want to run an action to open a port forward rule in the firewall. So when I go to port 50 of the firewall, it's going to go through to a specific VM and hit that VM on its internal port. So then this Ansible network command is run over SSH. So the typical way of running Ansible is to run it over SSH. So while Ansible is Python scripts and everything like that, the VIOS Ansible playbook actually requires SSH access, and it translates the commands that we're telling it to inside of Ansible. It translates them and executes them inside the VIOS router. So it is going to use an SSH connection here, but you don't need to know any information about that when you're executing the action. So we've got a separation of concerns here. The people who set up the network function are the ones who need to know credentials, and anyone who wants to execute actions does not need to know those credentials. They can perform the operations of opening ports and closing ports without any additional information. Just the authority, the authorization, and authentication that gets them into OSM. So, for your firewall, what did IT department do? We have two networks that exist inside of your OpenStack instance right now. So when you log into OpenStack, you're going to find a network called OSM External, and you're going to find another network called Private. And the private network is not going to be accessible from the outside. This is something that is internal to OSM, and there are no routes at all to it. The only route that it has is through the firewall. So when this instance was launched in OpenStack, they created it with one port here and one port here. So VIOS was manually deployed, no rules were configured. It was given this IP address with your Hackfest ID, as we mentioned earlier, and your username and password is OSM 2021. We can forget this part now because we can use open source MANO to perform our actions from this point forward. Yes, so I mentioned before that we have this shared directory where things are, and we're going to be taking a look at this Hackfest Day 1.7 PNF directory, which is where the next set of scripts will be found. So the first thing we're going to do is we're actually going to build our firewall. So if I grab my environment here, and I log in instructor 5. I log in as myself. And I go into my OSM packages directory. I can take a look at the Hackfest Day 1.7 7 PNF firewall build script. Now this one, you'll notice, is a little bit more complicated. It's actually going to be building the charms. So this is something that we didn't do in the checkpoint, where we just launched the very basic network function. In our case today, or this afternoon, we are actually doing a charmcraft build of the charms. So this will create the build environment for you, set up charmcraft, and make sure that the charms can be built. It's then going to take that build and put it into a directory, so when we create the package and upload the package, the binary version of all the charms, the compiled output basically, will be uploaded and stored with your descriptor, and it will be capable of being distributed. These two final tar.gzip files can be sent to anyone, and it's fully self-contained. No build is needed to be done at that point. So the next thing it does in here is, again, we take a look for your Vim ID, and we're going to register the IP addresses of your of your firewall with OSM. So this is where we're telling it the IP addresses so that it knows how to talk with our physical network function. This is required because this network function was already installed and already responds to this IP address, right? In my case, it's 95. In anybody else's case, it's 5 or 27 or whatever your IP address would be. So we need to tell OSM here where to find it. If OSM were responsible for it, if this were a fully fledged VNF, then it would know the IP address because, well, it asked OpenStack, hey, create me a VM, and oh, by the way, tell me its IP address. But because it wasn't, we have to do this PDU create with this information so OSM knows where to find it. So if you haven't already, you can go ahead and execute the build script. So here it goes, setting everything up, installing the necessary packages. Oh, sorry, you can ignore this no such file or directory. My apologies about that. So it's bringing everything that it needs in order to build this package into place. It's going to, prepare it and package it all up and get it ready to be uploaded to OSM. These symlinks can be ignored. I think lots of people are running this at once. This certainly went a lot faster last time I ran it. My apologies. Let's take a quick look at top here. Oh yeah, oh yeah. This machine is working hard for us now. So now, once again, cleaning out any prior versions of the descriptors from OSM. And this error not found is good the first time around because, well, we've never uploaded this before, so there's nothing for it to delete. Now it's doing the OSM package build, where it is validating and creating the tar.gzip versions of our packages. And here we can see it actually found that I have charm code that is going to be executed. a lot of, yeah. We've got the CPU pegged to 100% on this machine. We're getting our money's worth from the Etsy IT infrastructure right now. And this is the sort of thing that, this is why we say, you know, the YouTube videos will be up in, you know, a week or so after the Hackfest ends, because we're going to do things like edit this boring waiting part out of the video so that the video is much more concise. Just looking over here. I don't know if you can see this extra. So here I was just doing in another window, I'm just doing a top on this computer and we can see, you know, 0% idle. I'm sorry. Hackfest and stress testing. 2 in 1. You are right. Okay, maybe what I'll do while we're waiting for this to finish is I can show you here what the descriptor looks like. So in your, yes, you can ignore the could not open requirements file, no such file or directory. That's fine. That was something that I forgot to remove. It's not important. So we can take a look at the network service descriptor here. My apologies, my throat is getting so dry. So it's a very straightforward network service descriptor. All it's doing is it's describing that this network service has 2 interfaces, one that's management and one that's going to be on the private network. The interesting part comes into the VNFD, which is basically the network function descriptor file. This one says, well, how many instances will there be? And I'm going to go down here, you know, finishes the connection point so that we know how to hook up to our PDU descriptor. This name here, Gateway Public, and this name, VNF Internal, are both, I think it scrolled off the top here. Oh, here they are, Gateway Public and VNF Internal. This is how OSM gets it mapped to the final set of IP addresses. So when we take a look at the descriptor in here, it says, okay, plumb these to these internal things that we created in our PDU descriptor. Now for the interesting part, our day 1 and day 2 operations. In here, we're saying, okay, I'm going to have a execution environment. I'm going to name it VIOS config execution environment. It doesn't have to have any particular name. And the charm that I'm going to use is called VIOS config. And if I go into that directory, I can see that there is VIOS config source code and the VIOS config binary that was built as we were running these scripts here. So my network, like my PDU here, has already been launched and it's already available, but I'll finish with the description of the PNF here. And in here, it says, well, there are 2 primitive actions that I want to be able to run. One is adding a port forwarding, and that's going to take a rule number, a source port, destination address, and destination port. And then there's removing the port forward, which says what rule number to delete. And I think we'll spend more time on this on Thursday for people that are really interested. Here are the Ansible playbooks that we have that are actually going to run. Now I'll get into how the Ansible works a little bit later, how Juju interacts with it. We can go into more detail on that, but you can find the playbooks themselves right in here. So there's the add port forward and remove port forward. And this backup is not what I expected it to be. I misread the documentation and it didn't do what I thought it was going to do. So we're not going to actually look at backup and restore today. But maybe as part of our development day on Thursday, if people are interested, we could add these as additional backup and restore of configuration. So now that my package is built, I can go ahead and launch this as a network service. So Firewall launch is not going to, yeah, I thought you would be Mohammed. So here it is, we're just launching this network service. So if I now say OSM-NS list, I should see that I have an additional network service, which is my firewall. And it's still being registered with OSM right now. So this may take a little bit of time, but you should be able to see this eventually change over to a NS state of running. But while that's going, let me, breaking down the build charm. Here was the one line that should not have been here. This is that error no such file, this pip install requirements dev, that isn't needed. There were going to be some additional things that I was going to show, but ended up not going for that complicated of an example. So this here is really what this script should look like, and that's why you got that no such file or directory. It's relatively harmless. It was just left in there by mistake. So it goes in to that directory, sets up the environment, does a charmcraft build of the charms, and then copies that over to the destination directory for the packaging to pick up. Then we do this delete, and we clean everything up beforehand. This is just in case we want to run it a second time. Then it does the package build and the upload package. And then it did this telling OSM about the PDU. And this here, as I mentioned, is where we have this connection point of internal with the IP address that's going to be used for that, and the connection point of gateway public and the IP address that will be used for that. So now that you've run your scripts, if you actually take a look, I believe right in here you should have a, there it is, Firewall PDU that was created for you. So if we take a look at this Firewall PDU, you'll notice that the IP address will have been changed to the one that matches what you had in your spreadsheet. Continuing on with this. We launched the firewall service now. So now we can go into OSM. What that did is it created a network, an entry for this network service, which basically means it created an internal model, a representation of what the network service looks like, and it created an execution environment for our operations to run. And that should look like here in OSM. I'll log in. Oh, sorry, mine is still deploying. Ah, there we go. Okay, so mine is up and running. It's available now. If I take a look at my PDU instance here, I meant to show this before. Before, it said that the PDU was available. So this is the entry where basically I, sort of provided that information saying, okay, what's the public ID, what's the private ID, etc. And here I specified that the PDU is not allowed to be shared. So only one network service is allowed to talk to this PDU. So when I launch a network service that uses it, OSM will automatically flag this as being in use. And if I try and instantiate another network service that tries to use this same firewall, OSM is going to say, no, that's not allowed. You said that this is not a shareable resource, so only one network service can claim it at a time. There are other network service types or other PDU types if you decide that you want to make them shareable so that you can have multiple network services talking to the same physical network function. It is allowed. In our case, this being the firewall, and we're just interacting with it with Ansible, it could have been very well allowed that I made this shared, and then it would say, well, it's used by one service, but it's available for use with other services. So now I have my network service up and running, and I can actually let me see, what did I put in for our Hackfest? Day 1.7, firewall. Oh, I forgot. I had a watch progress command that you could run so that you could see what the progress of it was. Well, it would have been much more entertaining than watching the UI and just clicking refresh here until it turned green on us. So there is a firewall watch that you could use to take a look and see what other things are happening with it. So having said that, I've created one more script, and that is Firewall Actions. And this basically says, okay, if you execute this script, it's going to tell you, here are some actions you can run. And I obviously have an extra EOF at the end of it. But basically, it just tells you what things you can do. So desktop IP, show virtual desktop. Well, we don't have one yet. So there's nothing that's actually going to come back from this. So we won't be able to get an echo desktop IP. It's going to come back as null. So while we wait for that, what we can do is we're going to copy our Hackfest 1.5 checkpoint basic launch. Okay, so copy that to your home directory. So we have basic launch here. And what we're going to do is we're going to change the OSM-X to be private, like this. Copy the basic launch script to any current working directory, and then edit it, and it should look, we should have a difference afterwards that looks like this. We want to change the Vim network name from OSM external to private. I don't understand why things are still stuck in scheduled state. I'm looking at the resource usage. So when you look at your OSM-NS list, you're seeing an error. If you have received that error that Olivier is showing, self.sync, traceback, most recent call last, I'd like you to do an OSM-NS delete firewall. And we'll try launching it again in a little bit when things have quietened down on the servers. As an OSM administrator, there is an additional all projects flag that can be added that allows you to list things from other projects. I am going to go ahead and, where is it here? Launch my basic network service. And while that's going on in the background, let's go back here to see where we're at. So OSM, we had the watch progress, and then we're going to do an operation to add and delete a port forward. So once my network service is launched here, I should be able to see it on the private network. I should be able to see it start to come up on the private network. Okay, so in my case, can we launch the VNF even if the firewall is still pending? Yes, you can. And so when we take a look in OSM now, I should be able to see that I have these two up and running. And if I go into, whoops, sorry, I'm logged in as an admin here. If I go into OpenStack and log in as my instructor ID, I will see here that before I had an IP address that was on the external network. It was on the 18 subnet. And now we can see here that it got created with a private IP address. So if I do that OSM VNF list, I will see that my IP address is quite different now. Oh, sorry, by the way, it also shows the registered VNF that represents our PNF with its IP address. So here we can see that I've launched this VNF here on a private IP address, and that IP address is not reachable by me. So if I try and ping that, I get nothing. If I try and SSH to it, I can't. I have to go through a firewall. So if I take a look at my Firewall Actions now, I can see, well, there is a Firewall Action that allows me, sorry, just make this a little bit wider here. There's a Firewall Action that allows me to create a port forward. So I take this, copy and paste it. I'm going to say the destination port is 22, and the destination address is going to be this private IP address that I have. And the source port, because our firewall, our VIAS, and yes, it's not going to happen in the real world, but we do have our firewall open and listening to port 22 in the real world, and we don't want to, we need to tell it, well, I don't want to SSH to the firewall, I want to SSH to a service behind the firewall. So I'm going to pick a random port, 5022. So this basically says, whenever somebody hits us at port 1522, redirect it to go to my private service on port 22. So that will go ahead and execute the Ansible playbook to cause port 5022 to end up in the target VM. I can do an OSM NS op list. OSM NS operation list on the firewall. And this tells me, okay, the rule that the action that you requested, add port forward, has completed. So that means I should now be able to SSH to my VM, not at its private IP address, but at the IP address of the firewall, in my case 95, but on port 5022. Because remember, I said source port 5022 of the firewall is going to go to my private VM's port 22. And I am in. So I just traversed the firewall. And how are we doing for status? Does anybody have their PDUs up and running yet? Still scheduled. Well, we're getting close to end of day. We will keep this open for a bit here. But while we're waiting for that, are there any questions about the management of PDUs? Sorry, I'm looking at, oh, so there was my add port forward. The other thing I can do is I can delete the port forward. So this allowed me to go into here. Well, ls-al, we can see that I'm there. And then I can actually execute the, and I can say, remove the port forward, rule number 10, op list. It's currently processing and completed. So now if I try an SSH, I get a connection refused. So that's an example of actions that can be done on a physical network service. So my sincere apologies for how slow this is. We'll certainly do some tuning overnight. But in the meantime, any questions? Let's open the floor up to see how people are feeling. Oh, if you're getting the 409, that means you didn't do the delete in the checkpoint. You still have the previous copy of your basic VNF running. And so it's not able to upload the package. It can't delete it because you already have one running. So then creating a private instance of Hackfest basic. So what I did was I copied the file, and then I'll make it as a sed command here. Change OSM-X to private basic launch.sh. And then if we do a diff, it should look like this. And then we can go ahead and run basic launch.sh. And once that's done, we can say OSM-NS delete. We did an OSM VNF list. And then to add the port forward rule, I said this with my private IP address.
Sorry. Yeah, I just was saying that I was investigating the two OSM clusters, and I saw one error in LCM and Kafka. And most of the network service instances are not in instantiated state. So probably we might want to take a look at that offline and try to fix it for tomorrow, because something it's obviously wrong in the OSM cluster right now.
Okay, so we seem to have found a bug in OSM. Thank you everyone for helping us uncover this. You are now part of the future of OSM, making it a better product. So with that, we can call today's session to a close. We're going to be here still in Slack and be able to talk with folks and yes, Hackfest and stress testing. Thank you very much for attending day one. And tomorrow we'll hopefully have a much better and faster day.